Welcome to this introduction course on rotary evaporation. Today we will show you how to correctly use a rotavapor in your lab. The rotary evaporator or rotavapor allows you to efficiently evaporate your solvent or separate solvents mixture under vacuum and low heating temperatures. Let's look at the individual components before we begin. Firstly, let's have a look at the heating part. This part consists of a heating bath and a heating medium, the latter being either water for moderate heating temperatures or oil for temperatures above 100 degrees. The flask with your sample, to which we will come to later, will be attached to the glass joint and submerged into the heating medium. Upon reaching the lowered boiling point, the vapor will then travel through the vapor duct into the condensation area. This area is cooled by a chiller or by means of tap water. It will then be collected as a distillate into the receiving flask. To reduce the pressure inside the system, one needs to have a vacuum source. Here we have a vacuum pump that allows evaporation at a reduced boiling point and pulls the vapor into the condensation area. Lastly, we have an interface, which is the brain of the whole system. It enables the user to control all parameters from one single area and not setting them individually. And now, let's get to the sample. Here is our flask with the sample. We filled the 1 liter evaporating flask to half of its volume. The bigger the flask, the better, since the surface area will be bigger. Next, we attach the flask to the vapor duct and close the combi clip. We recommend not to tighten the combi clip too much, since we will be under vacuum. Now it is time to set the parameters. For the temperature, we recommend using the delta 20 rule. This means that the temperature between the heating bath and vapor temperature, as well as vapor and cooling temperature, is 20 degrees. In our case, we are using an ethanolic solution, so we will base our setting upon the thermodynamics properties of ethanol. We will set the heating temperature to 50 degrees and the cooling temperature to 10 degrees. Next comes the pressure. Since we target a vapor temperature of around 30 degrees, we look up at the pressure values for ethanol at that particular boiling point in the solvent table. As you can see, the desired pressure should be at 97 millibars. So now we go back on our interface and set the pressure at 97 millibars. Now it's time to start the distillation. Firstly, we start the chiller and check if the coolant is flowing by shortly squeezing the cooling tube. If you can feel a short pulse, it means that the coolant is running. Secondly, we start the heating and then we start the rotation slowly. Then we press start for the vacuum pump and we can submerge the flask deeply into the heating medium. Once this is done, we can increase the rotation speed to 280 RPM. This is the optimal rotation speed. The condenser loading is an indication of the distillation rate. You can check the condenser loading by looking at the droplets of solvents or by touching the condenser and assess where it is warmer. Right now, it's around here, so it's good. The maximum condensation level is at 75% and is shown by a line on the condenser. Here it's great. If it goes above the line, then your pressure will need to be increased. If it's lower, then the pressure needs to be decreased. Now comes the end of the distillation. We need to choose between concentration or drying. In our case, we had to dry our sample, so as you can see, the sample is now completely dried and is a white powder. We know that the evaporation is finished because there are no condensation droplets falling from the condenser coils. Or we can also see that from a sudden decrease of vapor temperature. If for your sample, you would need to concentrate, meaning that you need to have some solvent left in the flask, then you'll have to stop the process before complete dryness. In order to decide whether you should go for concentration or drying, you would need to know what is your next step. For example, if you need to do a purification with the liquid injection of your sample in the chromatography system, then you would need to perform a concentration. Now that our evaporation is over, we need to stop the system. We firstly stop the rotation speed and then the vacuum and aerate the system until it reaches atmospheric pressure. We then lift up the flask and stop the heating and the cooling. I can now detach my flask. Then we empty the receiving flask in order to make sure that our rotavapor will be ready for our next use. Our dry sample is now ready for further processing.